1930s, and this term was coined in his book he published, The Wisdom of the Body, which is a compilation of data looking at different experiments performed on the human body as well as other animals. And he said despite changes in the external environment, the human body had the capacity to maintain a relatively constant internal environment. And he said that 11 organ systems work synergistically or work together to maintain homeostasis. We identify the internal environment as being that as the what? What do we identify as being the internal environment? So we say the internal environment refers to the interstitial fluid. And how do we describe the interstitial fluid? Sorry, say again? Right, so this is a component of the what? Extracellular fluid. It makes approximately 80% of the extracellular fluid, and this is the fluid that surrounds the cells of the tissues of the body. Some books refer to this as the tissue fluid, and it's from the interstitial fluid that our cells, which make tissues, which form the organs, which form the organ system, receive all the materials that they need to carry out functions. Are we okay with that? And we listed several variables that must be regulated in the interstitial fluid in order to maintain homeostasis, to provide the cells with the materials that they need to carry out cellular function. We said that we took a look at the word homeostasis. It means a similar condition. And we said these variables will what? Oscillate around a what? Set point to establish a normal range. And we said that these variables will oscillate between this normal range, which is compatible to cellular function. If one of these variables was to deviate outside the normal range, the body must have the ability to what? Activate a what? Homeostatic control mechanism. So it must be able to activate a homeostatic control mechanism. And we said a homeostatic control mechanism is just a group of organ systems that work together to return a variable back within the what? Normal range, which is compatible with cell function. So we talked about the homeostatic control mechanisms. We listed the three components of a homeostatic control mechanism. And we said the three components would be that of a what? Sensor or receptor, control center, or integration center. And then we said the effector. Are we okay with that?
Yes.
We know the functions of all those three components. And we said that the interaction between these three components of a homeostatic control mechanism, they're governed by what are called feedback mechanisms. So these three components of the homeostatic control mechanism are governed by what are called feedback mechanisms. We said we have two types of feedback mechanisms. We have what are called what? Negative feedback, and we said in negative feedback, how we describe negative feedback? The sentence. How we define negative feedback. Exactly. So the actions of our what? Effector will drive the variable or the control condition in the opposite direction of the initial stimulus. Are we okay with that? So we're going in the opposite direction. We gave examples of the negative feedback mechanisms. We gave two examples. Is that correct? Yesterday we said blood pressure regulation and also solute or blood plasma osmolarity or solute concentration. So we gave examples for blood pressure, BP for blood pressure regulation, as well as that of blood plasma solute concentration and volume. So we gave examples of negative feedback. So make sure you can describe in detail an example of a negative feedback mechanism. When we say positive feedback, we said in positive feedback, the actions of the effector will drive the what? Variable in the what? Same direction. So positive feedback, the actions of the effector will drive the variable in the same direction. We said most of the homeostatic control mechanisms are governed by what? Positive feedback or negative feedback? By negative feedback. So most of our homeostatic control mechanisms are governed by that negative feedback, we can take in a look at an example of a positive feedback mechanism, or a mechanism that's governed by positive feedback, and we can look at parturition, or childbirth. And this will be a biological or physiological process which is governed by positive feedback. If you think about the onset of labor, when a woman is getting ready to go into labor to deliver her child, what will happen is she will have strong uterine contractions, and these strong uterine contractions will force the baby's head towards the opening of the uterus into the vagina for delivery, and this will cause stretching of the cervix. So at the onset of labor, in women, we have strong uterine contractions. This is contraction of our smooth muscle cells, one of the three types of our muscle tissue. So the smooth muscle cells line the walls of the uterus, will contract, and this will push the baby's head towards the cervix of the uterus, which is the opening of the uterus leading into the vagina. So this is called, push the baby's head against the cervix of the uterus, and this will cause a stretching of the cervix. This will cause the stretching of the cervix as that baby's child is pushing against the cervix of the opening of the uterus. This will cause it to stretch. Are we okay with that? Are we making sense? So this is going to be our what? Stimulus. So we have stretching of the uterus, or the cervix of the uterus is going to be our stimulus. So we have the stimulus, and the stimulus will then be detected by the what? Receptors, and we have what are called stretch receptors of the uterus. So we have stretch receptors that can detect this increase in stretching of the walls of the uterus as that child's head is pressed against the cervix. Are we okay with that? So we have the stretching of the cervix. This will be detected by stretch receptors of the uterus. And the stretch receptors of the uterus, so these are nerve impulses, they will what? Transmit this what? Sensory what? Input to the control center. So we want to transmit sensory input to the control center. The control center will be housed within the hypothalamus. So we transmit the sensory information to the control center, which will be housed in the hypothalamus. And receiving the sensory input, the hypothalamus will stimulate the posterior pituitary to release what? Oxytocin. So the hypothalamus will stimulate the posterior pituitary to release oxytocin. So we stimulate the posterior pituitary to release oxytocin. Oxytocin is a hormone. We saw the posterior pituitary also releasing the hormone what? Anti-diuretic. Did we cover that yesterday? Yes. The anti-diuretic hormone. So now we have two hormones being released by the posterior pituitary in response to signals from the what? Hypothalamus. So the hypothalamus will stimulate the posterior pituitary to release oxytocin. Oxytocin will stimulate contraction of the smooth muscle cells, SMC for smooth muscle cells of the uterus. So the oxytocin will bind to receptors on the smooth muscle cells lining the walls of the uterus. They will stimulate contraction of smooth muscle cells. So what will happen when we stimulate contraction of smooth muscle cells of the uterus? They will what? This will cause strong uterine contractions. everybody with me on that? That will cause the baby's head to push further against the walls of the what? Cervix. Is everybody with me on that? That will cause what? Further stretching of the cervix, which will then be what? Detected by the what? Stretch receptors. These stretch receptors will send the sensory input back to the what? Hypothalamus, which will stimulate the release of what? Oxytocin from the posterior pituitary. Oxytocin will then again bind to receptors in the smooth muscle cells on the uterus and cause more contraction. So we're going in the what? Same direction. Same direction. Is everybody okay with that? We're going the same direction, and this will continue until finally we have what? Delivery. Right out. Exactly. Woman's past her due date, or if the contractions aren't strong enough and she's dilating, they will stimulate uterine contractions by inducing labor with oxytocin. So if a female is past her due date, if she passed her due date, let's say her due date was September 4th, and she was today is the 4th, let's say it's September 1st, they will come in, they will inject oxytocin, it's called pitocin, it's a trade name. They will induce labor. The induction of labor will cause these strong contractions. We will stimulate this positive feedback mechanism until delivery of the child. Somebody just do me a favor. So are we okay with that? So we're taking a look at an example of positive feedback in which we're driving the stimulus or the variable in the same direction. The variable was the stretching of the walls of the cervix, release the oxytocin, stimulate uterine contraction, and we keep driving in the same direction until we have delivery. So make sure if you're asked to give a detailed description of a positive feedback mechanism, you can give this example. Another example will be blood clot formation. So if you're familiar with blood clot formation, the cascade of events associated with blood coagulation, that also is governed by that positive feedback. So we want to go ahead and spend a couple minutes reviewing some of the material that you guys worked on last class period and last period. We looked at our exercises and anatomical that. Oh, no. What did we say about antidiuretic hormone? We just said that antidiuretic hormone is the other hormone that's what? Released by the what? Posterior pituitary. And we said ADH is going to act on the what? ADH is going to act on what? What does ADH do? Right. How? It acts in the kidney. That's all we need to know for now, but we'll see. But actually, it'll stimulate the insertion of what are called aquaporins, which are water channels that increase the permeability of the kidney to water. So ADH is only mentioned because we said we want to identify two hormones, both oxytocin and ADH are being released from the posterior pituitary. So you want to take a look at some of the exercises or that you worked on last class period, and we took a look at planes and the corresponding sections. And we defined a plane as just being a what? An imaginary line that passes the body, and we said the section is the what? Physical cut that follows a particular plane. And we said we think about the dissection of the human body. We said that most of our appreciation of the physical relationship of one part of the body to another is directly derived from dissection of the human body. And we have three major planes and sections. So we just want to make sure we're all up to date with regards to the three major planes and the corresponding sections. We have the sagittal plane and section, which is a vertical, along the vertical axis of the body. It divides the body into right and left regions. We call it a what? Mid-sagittal if we have equal right and equal left halves. Are we okay with that? Then we have that of the transverse, horizontal, or cross-sectional section. It's on the horizontal axis of the body, and it will divide the body or a structure into what? Superior regions and what? Inferior regions. Then we have the coronal, or we have that of the what? also called the frontal plane section, which will divide the vertical axis along the long axis of the body. It will divide the body or an organ into a what? Anterior and what? Posterior, or we can say what? Ventral and. So we just want to make sure that we're okay with the nomenclature, identifying the major planes and sections. And as we take a look at another part of the assignment that you worked on last class period, we take a look at some regional terms. Look at some regional terms. The terminology used to describe the surface areas of the body. So we get some regional terms. And as we take a look at this figure, we had this figure or a similar figure on your handout last class period, and they're asking us to identify which regions of the body are associated with the named regional term. So this is a class, they're asking us, can you guys see fairly well? So they're asking us to identify the antebrachium. The antebrachium will correspond to body regions identified by the number what? Antebrachium will correspond to the region of the body identified by number what? Number 9. Everybody okay with that? Antebrachium corresponds to region number 9. As we take a look, the antecubital will correspond to region identified by the number what? 4. Antecubital, everybody's okay with that? Then we take a look at the axilla. The axilla corresponds to the region number 3. I don't know why this is going on. I don't know why. Then we take a look, they're asking us to identify the brachium. The brachium will correspond to structure identified by the number 10. Buttocks, we're good with that. Calf, everybody should be good with that. The costal region will correspond to the region identified by number costal. Costal will correspond to region number 11. When we say costal, we're referring to the what? Ribs. Costal, because we have what's called costal cartilage, which is hyaline cartilage, which helps attach the ribs to the sternum. So we have the costal region. The cubital region will correspond to the region identified by number what? Number 15, or it's also called the olecranon region. Then we have the dorsum. The dorsum will correspond to the structure identified by number what? 14. So the dorsum will be a composite of the costal region, the lumbar region, and they're including the buttocks region. So this will represent the dorsum, or the dorsal surface of the trunk of the body. Are we okay with that? You know, I think I know why. Number 14 will correspond to the dorsum. Then we take a look at the flank. The flank will correspond to the region of the body identified by the number what? 1. So it's the lateral surface of the abdominal surface area of the body. So we're looking at the flank. We're looking at the gluteal region. We know the gluteal region. The groin area will correspond to the area identified by number what? The groin area. Number 5, so that shallow depression at the inferior aspect of the abdominal region of the body blends in with the upper thigh. Then we have the ham. The ham will correspond to the region identified by number what? Ham. 16, so the ham also alternatively we can call the what? Popliteal region, referring to the back of the, or the posterior aspect of the knee region of the leg. Then we have the lumbar. Lumbar corresponds to region number 12, or the lower back region, referring to the 5 lumbar vertebrae. Then we have the pectoral region. You know the pectoral region will correspond to the chest area. We have the plantar surface will correspond to region number 6. And then we have the thigh area will correspond to region number what? 8. So make sure that you can identify the surface areas and use correct terminology. This is a very simplistic list of some regional terms. Make sure that you're familiar with that handout that you paired up with your classmate and can use those terminologies to describe various surface areas of the body. Are you okay with that? No. In addition to the regional areas, we took a look at the abdominal surface area. And as we took a look at the abdominal surface area, we said that the surface area can be divided into 9 regions if we employ the use of what? 4 imaginary planes, 2 vertical and 2 what? Horizontal. So we can divide the abdominal surface area into 9 regions by employing 4 planes. We have 2 vertical and 2 horizontal planes. One is to divide this large surface area into 9 different regions. We have the 9 different regions by employing these 4 planes. We said we divide the abdominal surface into 9 different regions. We said the practical reason or aspect for doing this is because it allows us to what? Localize or compartmentalize the location of the what? Internal organs. So as we take a look, if we're asked to identify these 2 planes, this plane will correspond to that of the right lateral. Keeping in mind the right side refers to the body being viewed. Left side also will correspond to the left side of the body being viewed. So this would be the right lateral plane. This would be the left lateral plane. Then we have the 2 horizontal planes, one superior, one inferior, and the superior horizontal plane is identified as the what? Transpyloric. So this would be the pyloric. We think about the pylorus, it's the inferior aspect of the stomach. So trans means going across. So this is just transecting the inferior aspect of the stomach. Thus the name transpyloric. The inferior horizontal plane is called the tubercular. So we have the tubercular. And the tubercular is just passing superior to that of our oxycoccus. And as we take a look at the oxycoccus, we have what's called the iliac crest, or the iliac tubercle, the superior aspect of the ilium region of the oxycoccus, thus the name transtubercular. And as we identify some of these regions, we take a look at region number 1. Number 1 would correspond to the what? Right hypochondriac. So it would correspond to the right hypochondriac region. Corresponds to the right hypochondriac region. And as we take a look at the right hypochondriac region of the abdominal surface area, we would find portions of the kidney. So deep within this surface region, we would find portions of the kidney. Also, we would find portions of the liver will be associated with the right hypochondriac region. Also, we would find that of the gallbladder will be associated with the right hypochondriac region of the abdominal surface area. We take a look at region number 2. We will call region number 2 the what? Epigastric. So region number 2 would be the epigastric region. So it would be the epigastric. Gastric referring to the stomach. So we know associated with this abdominal surface area, we would have the stomach, portions of the small intestine. Also, we find that of the pancreas would be associated with the epigastric. So we have the pancreas. We would also find portions of the liver associated with epigastric region. Then we have region number 3. Region number 3 will correspond to the what? Left hypochondriac. Will correspond to the left hypochondriac. The left hypochondriac will house portions of the liver. We have the portions of the left kidney. We have portions of the liver, left kidney, and one of our lymphoid organs, that of the spleen, will be housed within that of the left hypochondriac. In regions number 4 and 6 will correspond to the right and left what? Lumbar will correspond to the right and left lumbar regions, where we have portions of the right and left kidneys, as well as portions of the large and small intestines. So we have portions of the kidney, and the large and small intestines. Region number 5 will represent that of the what? Umbilical region. We have portions of our large intestine. Then we have that of region number 7. This will represent that of the right what? Iliac, or alternatively we can call it the what? Equino. Is that in the textbook? An alternative term. So we have region number 7 will be the right iliac or equino region. Within the right iliac or equino region, we will find the appendix. It's a small sac-like structure attached to our large intestines. So we have the appendix. Associated with the large intestine. The appendix consists of lymphoid tissue, and the function of our appendix, what does our appendix do? It phagocytizes or breaks down what? Bacteria. So it's part of the lymphoid system. It phagocytizes and destroys bacteria. So it consists of lymphoid tissue, and it phagocytizes bacteria. The appendix is highly susceptible to becoming infected as it engulfs bacteria. It becomes constricted, and what can happen? We can have infection of the appendix, giving rise to inflammation of the appendix or appendicitis. And if an individual came or presented itself to a physician with a deep burning pain in the right lower quadrant or the right iliac region, the first thing a physician will automatically think of is that they have what? Infection of the appendix due to the localization of this sac-like structure, which is very susceptible to infection and inflammation in this region. That would be probably the first thing they would begin to diagnose as being the problem. Then we take a look at region number 8. Region number 8 will be what? Hypogastric. We have portions of our large intestine as well as the urinary bladder and portions of the female reproductive organs will be housed within the hypogastricum. So we have the 9 abdominal surface areas that were derived by employing the use of 4 imaginary points, 2 vertical, right and left lateral, 2 horizontal, transtubercular, transpyloric, inferior and superior, respectively. So make sure you invest some time just to make sure that you can clearly identify the 9 abdominal surface areas associated with the abdominal surface area, and identify some of the organs associated with these respective areas. So make sure you take a look at this once again in your textbook. Just for your information's sake, we do want to highlight that alternative to using the 4-plane system, we also can divide the abdominal surface into 4 larger areas as opposed to 9 surface areas into 4 larger areas, in which we just use 1 vertical, 1 horizontal plane, divide the abdominal surface in the upper and lower left quadrants and the upper and lower right quadrants. So we just want to make sure that you're aware of that there is an alternative method used to divide the abdominal surface area into the 4 larger quadrants as opposed to the 9 abdominal surface areas. We use the 2 horizontal and 2 vertical. So make sure that you, it all depends. You know, in anatomy they focus on this, but really when you get on the clinical level, they actually do more quadrants. So it just all depends on your level. So as we take a look at so we're wrapping up our discussion on the assignment that you worked on last week. What we want to do today is introduce the topic for today's exercise, and today we will talk about body cavities. So today's exercise is entitled Body Cavities. And as we take a look at the human body, internally we have what are called body cavities. So we're looking at internal. So we just finished looking at surface anatomy. Now we're looking at just hanging out. Yeah, just take a look at that. So as we take a look at the body cavities, so we're looking internally now. We were looking at external surface area. Now we're looking internally. We look at the body cavities. These are confined space internal to the human body. So we're looking internally. And we can define our body cavities as confined space within the body. So it's confined space within the human body. So it's a space within the human body. And why do we have body cavities? Corinthians, what's the function of body cavities? Cameron. Oh, you got it? What do you mean? Go ahead. Different layers. Cameron, go ahead. Help you out a little bit. Exactly. So we think about body cavities. Why do we have a body cavity? This is confined space within our body in which you're going to what? House, protect, and support the what? Internal organs. Are we okay with that? So we're going to localize our organs within specific regions within the internal anatomy of the